Question 4. Function k is a transformation of the parent exponential function f. What are the domain and range of function k? So here's our function. We could put this in a graphing calculator to get a visual. Let's not jump to that. Let's start. Let's assume we don't have a graphing calculator. And let's make a table of values. And typically I tell students, let's start by picking these basic 5 x values and substituting them for x to see what it gives us for y, or in this case k, to see if we can get a better understanding of what the domain and range for this graph is going to be. So first off, we're going to take -2 and insert it for x in this function. So k of x equals -2 raised to the -2 power. Now, one place you're going to be really careful here is really what this is. This is a -1 times 2 raised to the -2 power. And we know order of operations, we always raise something, we always take care of the exponents before we do multiplication. So 2 raised to the -2 power is 1/4, or 0.25, and then multiply that by -1, we get -1/4. So really tiny number. So let's repeat this process, but this time we're going to replace x with a -1. So 2 raised to the -1 power is 1/2, or 0.5. 1/2 times -1 is just -1/2. So again, a really tiny number. All right, and now we're going to go back and we're going to substitute 0 for x. Anything raised to the 0 power is just 1. -1 times -1 is -1. Almost there. Now we're going to replace x with +1. 2 to the first is 2. 2 times -1 is -2. And then finally, let's replace x with +2. 2 to the second power is 4, times -1 is -4. So real quickly, let's make a makeshift graph here. I'm going to erase all this. We're going to graph those points. So the first point is -2, -1/4. So that's left 2 and down just a smidge. The next point is -1, -1/2. So that's left 1 and down just a little bit more. We're just estimating. Then we've got the point 0, -1. So it's just down 1 unit. 1, -2. That's right 1, down 2. And then finally 2, -4. That's right 2, down 4. If you know anything about exponential function graphs, they're always going to approach a value and kind of see what that value is in this case. See, where as we move into the right, we're going further and further down. But as we move up, we're getting closer and closer to this x-axis. And we could confirm this by putting it in the graphing calculator. But this is our graph. We can see for the domain, and really there's no question on the domain because all 4 answer choices have the same domain from -infinity to +infinity for x. This just means there's no x value this graph doesn't cover. And recall, domain is how far left and right a graph goes, essentially. This graph is going left forever, and it's going down into the right forever. The range is the question. So the range is the y values. And we'll notice our largest y value is -1/4. So that's less than 0. So we know it can't be this one because this says y is greater than 0. Could be this one. Y is less than or equal to 0. Can't be this one because it's saying the range goes from negative infinity to positive infinity, and that includes positive y values, so we'll mark that out. And this last one says y has to be less than 0. So really the question here is, can y equal 0? Is there a number we can substitute for x that gives us exactly 0? Now let's just verify this. Let's use the calculator at this point. So we know negative 2 to the negative second power was negative 1/4. What if we do negative 2 raised to the negative fifth power? What do we get? Really small number, but not 0 yet. Let's do negative 2 raised to the negative 8 power. Smaller number, still not 0. Negative 10 power. And you can see we get an E. This just means a number in scientific notation that's really, really, really small, but it's never going to equal 0. So therefore, the range cannot be less than or equal to 0. The range has to be less than 0.